Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Hey, good evening, everyone. Welcome to day 21st of our Learn and Earn series. And quickly in the chat section, you all please give me a +1 if my screen is visible and if my voice is clearly audible. All right. So, hello, everyone. Hello, Naikaj. Hi, Shubham. Thanks, Sachin. Thanks, Rish, for confirming. And yeah, homework's question will be shared in the Discord channel. That will be done by today only. Hi, Sneha. Thanks for confirming. And first of all, guys, a very big congratulations to you all. You know, we have completed 2/3 of our session. So that's a very big achievement. So yeah, congratulations to you all for maintaining the consistency and for doing practice every day. Let us just wait for a few more minutes. Let our fellow friends also join, and then we shall be beginning in a minute or two. All right. Till then, everyone in the chat section, let me know what is the streak that you have maintained till now. Let us see, let the session start, and then we will be seeing the questions that we are going to do today, right? That's great when you Gopal. 21 is a great number. Okay, so if you missed it, you can always go to this playlist and you can access the lectures from there. They are available. All the lectures from the series are available there. Great, Sachin. That's a good number. Rather, that's an excellent number. That's great, Adarsh. Very nice to hear. Great, Shubham. Yes, we are here to help you out. Any doubts that are coming up, do let us know. We will help you, Himanshu. All right. Thanks, Shubham. That's a very nice comment and great, Mishkat. This consistency, this practice is exactly the thing that we need. So, you know, if you all are with such a great enthusiasm attending all the lectures and doing all the questions, then that's a very good news for all of us. All right. Okay, I guess we are good to go with our today's session. So give me a quick +1 in the chat section if we are good to start our today's session. Thanks, Mishkat. Thanks, Sachin. Thanks, Neha, for this wonderful comment. All right. Okay. So the first question that we are going to discuss today is, okay, thanks, Anik. Thanks, Neha. So the first question is longest distinct characters in string. And the question statement reads as, we are given a string S and we have to find the length of the longest substring with all distinct characters. All right. So we know that substring is a continuous part of the string, right? So say the example is this geeks for geeks, and the output is 7, because the longest substring with all distinct characters is that is mentioned here. Okay, so okay, let us understand with examples. See, this is our string given. Okay, okay. So now tell me, what is the longest substring with all the distinct characters in it? All right, I'll just share the problem link. Give me a second. All right, guys. Okay, and just give me a moment, right? Just a second. Okay. So yeah, tell me. Yeah, the question is that we have been given a string. Okay, so this is our string S, and we need to find the longest substring in it, which is having only distinct characters, right? So let us start from here. First of all, we have G. Okay. Yes, I'm very happy to see that answer. Okay, first of all, we have G. Okay, so okay, G is the substring. Then GE. Are any characters repeated? No. So GE also. Then E. We can't add E because here E is getting repeated. So let us say we are starting a new string from E. Then we have K, then S, F, till here. Okay, till R. We don't have anything in repetition, right? Then we have then we can start from here. We have started this from E. Then we can start from K as well. We have K, S, F, O, R, G, E. All right. This can also be one of the substring. If we start from S, we have S, F, O, R, G, E. Right. This. If we start from F, we have F, O, R, G, E. Next we have O, R, G, E. Next we can have RGE and so on. All right, here the E is in repetition, so from this point we can have EKS. Okay, are all these examples clear to you? Yes, Shubham, you are correct. Are all these examples clear that how the substrings are getting generated? Because E tuck isliye because after E you can see this E is getting repeated, right? So you can't add E here. All right, because it is getting repeated and we want only distinct characters in our substring, right? So the longest length is, I guess this is the longest string that we have generated, which is 1 2 3 4 5 6 7. Okay, that's length is 7. All right, now let us say example string is A. What is the length of the longest substring without any repetition in this case? All right, Meshkat, Himanshu, that's the right answer. Adarsh, only one. Okay, because all of these are repeating, so at max we can have one string, which is A. Okay, so now tell me, let us go back to our first example. This was our first string. Let us keep it till here. Now tell me, while we were iterating through this string, what is the first thing that you did? Suppose we are at this point. Okay, we are at character G. Are we adding character G to our answer? And this is the length that we have till now. Okay, we can add. We can let us keep 2 pointers, right? So let us say our one pointer is here, and for now the other pointer is also here. Okay, so we can add G. Now let us say next pointer we have shifted to E. Can we add E in our answer? Yes, we can add. So let us say we have added E. Now let us say our next pointer has the second pointer. See, the first pointer is at G only, right? Our second pointer has shifted to E now. Okay, this next E. Can we add this E now? Yes, not second E. Why? Because as we can see, this E is already present. One E is already present inside it, so we are not going to add it, right? Cool. Is the concept clear what we are doing? So, aren't we doing this thing that, okay, we are checking for the last index in which this E appeared, right? Let us say we have a vector to do that. Okay, let us say I have maintained this. Okay, so E comes at, say, if after minus 4. Okay, so here is E. Let us say we are updating the index at which each of the character is occurring, right? Where is G occurring? It is at index number 0, okay? G will be A, B, C, D, E, F, G, okay? So here we can write 0. 6 is at index number 0, right? Yes, we will be maintaining count array. Next, when we are at E, where is E first of all appearing? It is A, B, C, D, E. So let us say we have updated the index value at E, right? Now, when we are iterating through it, when we will come through this repeated character, what we will check? We will check that if this character was repeated before or not, right? If this character was found before or not. All right. We will try to check for that index that, if map at E is already present or not, right? Yes, that can be one of the method. Yes, so that we are doing, we are checking if it is present or not. If it is not present, then we will update our length, right? And if it is present, then we can, simply keep on. If it is not present, we will update our length, and if it is present, then we will discard it, right? Now, I will just explain to you another approach. What I am doing is, I am maintaining a, say, of size. All right, and say this is my string. What is the length of the longest, and let us say I'm initializing all of them with -1, okay? This is an array or vector or map, you can say, that I have maintained to keep track of the last index where the character was present, and I'm initializing all of them with a -1. All right, tell me the length of the longest substring without repeating character in this string. 4. All right, ABCD is the answer, right? Okay. All right, now let us see what we will do. Okay, first of all, we will start our iteration at this point. Great. And we are using 2 pointers here, I and J. All right, 2 pointers will be used because we are using a kind of a sliding window approach. So for that, we need one starting point and one ending point. All right, let us say J is our starting point and I is our ending point. Okay, so currently my I is pointing here. All right, in J, I will store whatever is the maximum value of J that I have till now. All right, or if there is any value of the current character that has already been present. Is this line clear to you all, what I have done here? And let us say I'm initializing J with 0. Is this line clear? Yes, that's right. Rest will be I minus J plus 1. Rest is our answer. Okay. Okay. So what I'll do is I will maintain a variable J, right? That is my starting point of the index of the string, right? So what shall be my starting point? The starting point should be such a point so that after that starting point, from this J to I, there should be no any repetition. Is this clear? My starting point should be such that from J to I, there should be no any repeated character. Is this thing clear? So that's why I have maintained this variable j, right? It will give me the index, it will give me whatever is the maximum value, right, of j, or the index value of the current character of the string. So let us say if my I is here and if j was 0, so what is the value of j now? What is the value of j when my I have just started the loop from a? Will it be 0? Because currently we are comparing 0, current value of j is 0, and value at the see, map has not been updated now. All right, so mp at s of I, right, which means that s of I is what, a. So what is mp at s of I? Mp at a, we are having 0. All right, say this is for a. Okay, this is b, c, d, e, f, g. We are having here -1, -1 plus 1 will be 0, so we are comparing, so maximum value of j will come out to be 0, right? All right, next we will be updating rest. What will be the rest? Rest will be the length that we have obtained till now, which will be j minus I plus 1. Cool. And then we will just update our map. At our map of s of I, we will add the current index. Okay, so say map of a will be here, it will be 0, because this is the first index where it is occurring. All right, so see, basically what we are doing is, look, if a string is given, okay, first of all try to find out j. What is j? J is the starting point. Okay, first thing, we have a variable j. What is j? J is the starting point of the substring that we are taking into account. All right. Now see, where will this j point? J will point to such a character so that after that the character has never been repeated. All right, I will just run, I'll just do a dry run for this code. Okay, we have map of s of I, we have j, and we have res. J is every time maximum of j and map of s of I plus 1. Okay, tell me, currently I am at a. Alright, if I am at a, what will be the value of j? If I am at a, yes, j will point to the starting index, that's correct. But tell me if, and okay, let me write a I variable as well. Initially I is 0. Okay, j will be 0. Okay, why 1? See, j is maximum of 0, comma. What is map at s of I plus 1 right now? -1. Say we are using a count array where every variable is initialized with -1. Okay. All right. So -1 plus 1 will be 0. So value of j is 0. Okay. So what will be the value of res? Say res is j, sorry, I, it will be I minus j plus 1. All right. This is res. So value of res will be 1. And at mp of s of I, we can add, at a we can add 0, because a have been occurred at 0. All right, now tell me, I am at this point. Okay, my I is 1. If I am here, what will be the value of j? If my I is at, yes, that can be one of the approaches, but I want All right, tell me if my I is at 1, so what will be the value of j? Yes, that's correct. We will be calculating j minus I plus 1. Okay, value of j will be again 0. Let us say 0. Now what will be the value of res? I minus j plus 1. Will it be 2? Right, it will be 2 value of res. And is this clear that till this point we have the length of string with distinct characters as 2? This is also clear? Because you can see A, B, they all are distinct, right? Now let us say my pointer is at here, C, okay? My end pointer, right? So value of I is 2. Now tell me what will be the value of J? Okay, in B, I will update as 1. What will be the value of J? Again comparing, current J value is 1. MP at S of I is minus 1. Currently we have MP at C as minus 1. Minus 1 plus 1, 0. See, this map count that I have created looks like this, okay? It is initialized with minus 1 for all the characters, all right? A, B, C, D, E, F, G. All right, and then every time we are adding the current index value. For A, we have added 0. Here we will add 1. Yes. So now J value is 0. What will be the rest? Rest is 3. Okay. So is this thing clear that till this point we have the length of the substring as 3, which is having no distinct character? Like, are you guys able to see this? And then we will maintain C as 2. Is this thing clear that till this point? All right. Now let us say our I is at B. Okay, now look at this carefully. When I is at B, just a second. Okay, so when I is at B, right? I's value is 3. Tell me what will be the J value? 0. What is the mapped value of B? What we are currently having at B? 1. Inside our map, what is the value stored for B? 1. All right. So 1 plus 1 will be 2. So now what will be the value for J? Two. Value of J will be 2. Fine. What will be the value of res? See, J is now pointing to 2. So is this correct that our J pointer has now shifted here when our I pointer was here? Is this logic clear? Our J pointer should have had to shift here, right? Why? Because this B is getting repeated. So if this B is included, then you can't include this B. Is this point clear? If you are including this B, then you are not allowed to include this B, right? So that's why our J pointer got shifted here, right? And as you guys can see, from this point to this point, the longest substring with distinct character, that is CB, the length is 2, and that is what we are going for. We are getting for our rest 2. Is this concept clear? What are we doing? See, using the map, we could have done it. Okay, that's one of the ways, but I want this way to be there because I guess it is, it will help you to understand the logic that, yeah, that what we are exactly doing, right? You can, in with the help of this logic, you can easily, visualize that how these values are getting shifted, how sliding window is getting used, right? rather than using in map. It will take say maybe 4 or 5 lines to do this, right? For this code 3 lines are enough. You just need to maintain the last occurring value of the current character. Okay, in J what we are finding the last occurring index of the current value. Just think over it, like what we are doing. See, coding is what you need to code smartly, right? There can be several ways to code a question, but we need to do it in the most smart way. All right, so J is last occurring index of the current character. Okay, see what sets you apart than others. If you apply some logic, all right, which is like very innovative, which is something new, right? It will enhance your logic, it will enhance your thinking skills. Thanks, Rajendra. Okay, is this clear what J is holding? J is holding the last occurring index of the current character. Alright, and once we have that, we can find the current length as I minus j plus 1 and we can keep it updating. Alright. Okay, let me show you here. First of all, let me maintain a map. Okay, we have map, we have j, we have I, we have res. Initially, my map is having value minus 1, minus 1, minus 1. Okay, till this point it is clear. I have initialized my map with all the values as minus 1. Okay, great. Now you guys are going to tell me. Okay, let us say my I is here. Value of I is 0. Okay, and let me write what j is. Great. Now tell me what will be the value of j. Question link has been shared in the chat section. Tell me what will be the value of j here. Just think very carefully. J is also 0. Great. What will be res? You know what is this MP at S of I is, right? S of I means the S of current character. Why res will be 0? Res is I minus j plus 1. Tell me what will be the value of res? 1. All right. Let us update our current index value. So S of I is A. Can I write 0 here? Clear? The first occurring index of A is at 0. Till now, is everything clear? Now, let us say I have shifted my I to here. Okay. Value of I is, say, 1. Now, what will be the value of j? Map at S of I. S of B is currently holding minus 1. So, minus 1 plus 1. What will be the now current value of j? Zero. Great. What will be res? What will be res now? I minus j plus 1, 2. Let me update B as the current index value. Till now, is this clear? Okay. Let us say now my I is here. Okay. Let us say my I is here. The value of I is 2. Okay. What will be the value of j? 0. Map of S of I means S of C currently I am having as minus 1. So 0 minus 1 plus 1. Again, I'm getting it as 0 only. Length will be 3. Great. And also we can see that till this point, the length of the longest substring is coming out to be 3. Cool. Okay. Now, great. Okay, so now tell me, now comes the point, okay, why, what is the use of this map and all. This is B. Let us say my I is here. So value of I is 3. What will be the value of J now? Thanks, Rish. That's nice to hear. What will be the value of J now? Maximum of J. What is the last value of S of I? What we are having at S of B? What we are having at S of B? That is 1. Okay. 1 plus 1. So what will be the value of J now? Max of 0 and 2, 2. So J is having here 2 and the value of rest will be 2. Cool. And we will update our B as 3 because that is the current index. Okay, so now is it clear what are we doing in this question? How are we updating the map values and how are we adding values to it? How are we updating length? Is this clear now? Okay, so give me a quick +1 if we are good to go to the coding part. Okay. Yes, thanks everyone. All right, now let us say I'm starting. Yes, you can do it either way because actually inside the loop, I like I as my loop variable. So that's why I use j outside. So we have j as maximum of j and whatever value we have at s of I plus 1, right? Rest will be maximum of rest I minus j plus 1 and we will be then updating our map as the current index value. Initialize j as well. Great. And we will return yes. All right. Great, guys. So this question has been done, and I hope the logic was clear. The next thing is this question can be done with the help of that map thing as well. As in, when you find a repeated character, you can just decrement the length. That can be done. So, you guys can try that approach for your homework that you can take as your homework. Now, let us start with our next question. And okay, so this is our next question. Yeah, hash set can be used. Yes, thanks everyone. Okay, so I have taken 256 because so that here I do not need to write s of I minus 0. That's why. All right. Yes, 26 is also enough. You can use 26. And in that case, you will have to write minus 0 here. So to avoid that, I just use 256. All right. So the next is overlapping intervals. Okay. So this is the question link. All right, let us do it in session 1 so that everyone can get the approach that we are using for this question. So the question is, we need to given a collection of intervals, the task is to merge all the overlapping intervals. All right, we need to merge overlapping. Now what does the overlapping interval means? For example, we have 1 3 2 4 6 8 9 10. Say we have 1 3 2 4 6, 8, 9, 10. Okay, now we need to merge the overlapping, right? Overlapping means if there is any value whose starting point is coming before end point of any interval, then we should merge them, right? Like whatever the merge means in a common concept that we have to do. So here you can see we can combine both these intervals and we can write them as 1, 4. We can write this as 6, 8, and we can write this as 9, 10. Is this clear? The question and the example? Clear? Right. So, okay, tell me, what are we doing? I mean, it's a very common concept, right? What commonly are we doing to check if any interval is falling inside it or not? We overlap. All right. No, like, see, what I meant is we have added 2, say we have added 2 inside this interval, right? On what basis did we decide that 2 should be added inside this interval or not? On what basis was that decision done? Okay, sort the starting point, then check endpoint with the starting point. Okay, see if overlapping. What we are comparing is, no, why compare to end of first is exactly, Vivek, that's right. The end time of last interval that we have, end time of last interval should be greater than start time of first interval. Is this clear? Is this clear what we are doing here? Yes, of course, we will be maintaining an additional vector for it. Okay, the end time of the last vector that we have, that should be greater than the start time of the next interval. Cool. And if it is like that, then we will simply insert it. We will simply merge those vectors. Okay. Okay, we will simply merge those. Now see, after merging, shall I write it as 1, 3 or 1, 4? After merging these two intervals, shall I write it as 1, 3 or 1, 4? Yes, Venugopal, thanks for it. That's right answer. Yes, 1, 4. So what is the second step that we are doing? Okay, see, the first step that we did is comparison. And in second step, what we did, that update the last interval. And now suppose that if that starting point is greater than this end point, then what we will do? In else condition, if starting point is greater, we only need to check the end point of first interval. All right, update rest. Else, yeah, how shall we updating? Suppose there comes the index, for example, this is 6, 8. Okay, its starting point is greater than the end point of the previous interval. So what shall we doing with 6, 8? Shall be adding it on it in our answer vector. Okay, adding it in our answer vector. Okay, are these three steps clear? Yes, Adarsh, Meshkat, Naikash, all of that is correct response. Are these 3 steps clear to you all? Give me a quick +1 if we are good to go to our coding section. Okay, and I want you all to help me with the coding. We have to return the merged intervals. Great, guys. Okay, so now tell me, what shall I write here? I have created this res 2D vector that we need to return. Tell me, what shall I write here? The next thing, what are we going to do? Just use the same logic that we used in the dry run just a second ago. I think we can avoid that step. Why? The 2D vector is already given to us, so we don't need to push any and to make any additional 2D vector. Sorting. Okay, great, Adarsh. We will be sorting our intervals. Yes, Shubham, that's great. You can use whatever approach suits you. All right. Now, shall I add my first interval? Because that will be always there. Okay, is this clear that I have added my first interval? Let me declare the size variable as well. For what? Like a vector of pair, you want to use it for what? Now tell me, from which point shall I start my iteration? I is equal to what? I should be is equal to what? I'm adding the intervals now. Yes, great, Adarsh. I should be is equal to 1. Intervals is pushed because the first interval will always be there inside it, right? You can't ignore the first interval. So if first interval is there, and now on the basis of this, we will keep on inserting the other intervals. All right. We need to have a starting point, right? On what basis are we going to check if the current interval is overlapping or not? Great, everyone. So we can start for int I is equal to 1, I is less than n, I plus plus. All right. All right. Now, what is it that we are checking? What is it that we are checking? What is that if condition? The starting point of our current interval, that should be less than or is equal to whatever value we have added last, right? If it is so, then we will just simply update our endpoint as maximum of that endpoint or current intervals endpoint. Is this clear? End time should be less than start. Okay, yes, that should be less than or equal to. Okay. All right, is this clear what I have done? I have how I have updated this res and how are we, inserting it inside. And let us say if it is not overlapping, then we will simply add it to our answer vector. All right. And then we will return our answer vector. Is this code clear? Okay, in line number 19, what are we doing is, see, Let us say this is the intervals. Are these two intervals overlapping? Are these two intervals overlapping? I'm explaining line number 19. Yes, they are overlapping. It means they are going to get merged together, okay? Their starting point will be 1. See, starting point, this 2, that is for sure, it will never be less than 1, okay? Because we have sorted our array. So this is for sure that this is never going to be less than 1, right? It will always be greater than 1. Okay, so starting point will remain 1 only. Now tell me, what will be the ending point of this merged interval? If you are merging these two intervals, then what will be the ending point? 4, right? So why 3? Yeah, it will be 4. It will be the maximum of the end point of these two intervals, all right? Yes, it will be the maximum of 3 and 4. See, starting point will be minimum of 1 and 2, and end point will always be maximum of 3 and 4. Okay, now see, this is taken care by sorting because we have already sorted our array. So this is taken care by the sort that we did in the beginning, and for this we are doing the comparison. Okay, is this now clear? The line number 19. Yes, rest dot back refers to the last element ending point. Yes. Okay, so give me a quick +1 if this question and code and logic is clear to you all. Great. Okay, so we are good to start with our next question. Before that, I want every one of you to please give a like on this video. Everyone who is watching this video, just please give a thumbs up. Every viewer, because the count of viewers should be equal to the count of thumbs up that we have. Thanks, Alankrit. Thanks, Meshkat, Adarsh, for confirming. Thanks, Lucifer. All right. Yeah, time complexity will be n log n, of course, because we have used the sorting algorithm here, okay? So now before moving on to the next question, let us have a small discussion about, say, what is our favorite algorithm? Each one of you can quickly write it in the chat section. What is the favorite algorithm that we all have? Let us see which is getting the maximum votes. Hashing, okay. Actually, that's my favorite as well. I prefer this hashing technique a lot. Yes, binary search, Kaden, BFS, Moore's voting algorithm, all right. We have Floyd Warshall, nice. Okay, Vivek is for BFS, Ritesh is also for BFS. All right, I guess we are having all the different algorithms and I don't see a winner here. Okay, Alankrit, that's merge sort, other Dijkstra's algorithm, nice. All right, like I'm happy to see the variance of the answers. Great. Okay, tell me one thing. Before using a binary search on the question, what is the first thing that you look for? Yeah, sorting algorithm is also nice. Like, it really sorts most of the questions. So yeah, sorting is a great algorithm. All right. So yeah, tell me this thing. Before applying a binary search on any question, what is the first thing that you look for in that question? The prerequisite condition for a binary search? Sorted. The array must be in sorted order. All right. Let us see how many of you are getting this answer. Okay, the array shall be sorted. Okay, that's the right answer. Now let us see our next question. That is allocate minimum number of pages. All right. So the statement reads as, you are given n number of books and every ith book has ai number of pages. All right. Okay, question link. Okay, so now you have to allocate contiguous books to m number of students. There can be many ways or permutations to do so. In each permutation, one of the m students will be allocated the maximum number of pages. Okay, so out of all these permutations, the task is to find that particular permutation in which the maximum number of pages allocated to a student is the minimum of those in all the other permutations and print this minimum value. Okay. Let me explain the question. I'm pretty much sure there is confusion for this question. Okay, so let us see. Let us say array is given to us. Okay, now what does this array represent? It represents the number of pages in a book. Okay, say there is one book in which there are 10 pages, in another book there is 20 pages, then 30, then 40. Is it clear? Now see, let us say we have two students here. Okay, and you need to divide these pages in two students. What are the ways in which we can do this? Either divide it as 10, 20, 30, 40. Then we have 10, 20, 30, 40. Okay, then we can have 10, 20, 30, 40. Why I am doing in this way? Yes, that's why I'm explaining the question. See, why I'm doing it in this way? Because the books must be allocated in a continuous manner. Okay, so see, the question was, an array is given to all of us. An array is given to all of us. All right, we need to the array represent the pages of a book. All right, so we need to distribute these pages to students, all right, in such a way so that any student who is reading the maximum number of page is minimum. All right, what do I mean by that is, if two students are reading this much pages, one student has to read 20, other is reading 90 pages. Okay, here one student is reading 30, other is reading 70 pages. Here one student is reading 60 and reading 40. Okay, what is the maximum number of pages for this division? Okay, tell me guys, what if we have divided book in this manner? Yes, it is a kind of the painter's partition problem, right? Say we have divided the book in this manner, right? So now tell me, what is the maximum number of pages that a student is reading? All right, 90. If I have divided it in this manner, then what is the maximum number of page a student is reading if this is my division? 70. Great. And if I have divided the book in this manner, then what is the maximum number of pages a student is reading? 60. Great. Now let us say the students that we have, they are not much of a very book reading kind of a students, and all right, they don't like reading books much. So what they want is, they want to divide it in such a way so that the maximum number of pages that they are reading is less. All right, so tell me, out of these three divisions, which is the most optimal for students? This 61. Okay, great, Azmira, that's right answer. So we are going with this division. All right, great. Now tell me, how many here are the person who like book readings, like who can read maximum number of pages? Like, book reading is a nice hobby, right? But still, mostly people don't prefer reading pages. How many are here book readers? Yeah, I can see most of us are not. Yes, comics are nice, Adarsh. Comics are like, they have these pictures and visuals are all. Yes, novel reading is also a nice hobby. And yeah, actually, we should all develop a reading habit, right? That's the nice thing. All right. But the students that we have here, they are not much interested in reading books and they want to have the minimum number of division. All right. Okay. So we need to help out these students. We need to do the division in such a way so that, they can read the minimum number of pages. Now let us see. Let us say, has it occurred in any of your minds that we can use binary search here? Okay, this calm like that's Java T point. Okay, nice. Okay, tell me, has it appeared that we can use binary search in this question? Let us say the array is not sorted, right? That is not mentioned in the question. Yeah, I will just be explaining how we can use binary search. Because see, as the array is not sorted, so at first it may appear that, exactly, first time it will never appear to you that you can use binary search here. Yes, we can use. Now let us say it is, the first time this will never come. It is with practice only. All right. First time it didn't came in my mind as well. Let us see. Let us say, what is the minimum number of pages that a student can read? 0. Like, a student will say, okay, I'm not going to read any of the books, right? And what is the maximum number of pages that a student can read? Let us say a student is saying that, all right, I'm going to read all the pages. Okay. Suppose he is like, very studious one. So, what will be the maximum number of pages? That is all right. Now, the range in which the page division lies, it is from 0 to 100. Now, is that range in a continuous manner? Exactly, Krish. Is that division in a continuous manner? Okay, so as we can see, the space, all right, on which we are applying our algorithm, that is in a continuous manner starting from 0 till 100. So as now it is in continuous increasing order, so now can we use binary search here because it is in a continuous increasing order? By continuous, I mean that, if you have assigned, say, book with 10 pages, then you need to assign the next book with 20 pages. You can't, skip it and then assign book with 30 and 40. The array is not sorted. Yes. So our search space, that is in increasing order, right? So now we can use the binary search. All right, got it. Very good. Now let us see what we are going to do in this binary search. Okay. Let us say, for example, of course, we will use the algorithm of a binary search. Let us see, I'm taking that, let us see, I'm taking that a student can read 40 pages. Currently, I'm checking if 40 is a valid number or not. Okay. Now tell me how we are going to check it if 40 is a valid number or not. So let us say 40 is the maximum number of page that a student is going to read. Okay. So if a first student is reading 10 pages, okay, I have two students, student number 1, student number 2. Okay. A first student is reading 10 pages. Can he read 10 pages? The maximum limit is 40. Yes, exactly, Nikus. All right, in monotonic function, we can apply binary search. All right. Let us say for now, we are having the maximum limit as 40. Yes, a student one can read 10 pages. All right. Let us say this is the next book with 20 number of pages. Okay. Can a student read book with 20 number of pages? The same student who has already read 10 pages. Can the student read this new book? All right. And you can't, divide the pages. If it is 20, it has to be 20. You just can't give 10 pages to the student. Yes, the student can. 30. Okay. Now the same student can the student read this new book with 30 pages? The same student, can he read the book with 30 pages? No. Why? Because maximum limit was 40. If you will give this 30 page to that student, See, the student can't read. Why? Because if you will give 30 student to the same 30 pages to the same student, he has already read 30 pages. After this 30, it will be 60. So that's not our limit. The limit is 40, right? So now we will jump to our next student. So our next student is next student is going to read 30 pages. All right. Can we give 40 pages to our next student? Yes, 30 is definitely less than 40, but till now the student has already read 30 pages. Okay, he has started reading from the beginning. He's not reading only this book, he's reading all the books from the beginning. So he has already read the book with 10 pages, then 20, then 30. Okay, so we can't give this 40 pages to the student, same student. All right, so we will need another student and we will give him 40 pages. Okay. Now tell me, we will need 3 students if our maximum limit is set to 40. All right. But we had only 2 students. So do you think the max limit 40 is the correct choice? Forty is just say I am just taken a random value. Say we are just checking for 40 if we can assign the maximum page value as 40 to our students or not. Okay. All right, so this is not a correct choice. Okay, so it means we need to increase our page number. Say the our max limit was 40, maybe we can do it to 60, right? All right, is this clear? Let us say, so we will keep on increasing our max limit. Let us say now our max limit is 60, right? We have said that student will be reading a maximum of 60 books. Let me explain for that. 10, 20, 30, 40. All right, we have the student number 1 and max limit is 60. Max limit is 60 pages. Okay, this student number 1, can he read 10 pages? These numbers are, you will, our search space is from 0 to 100. We will check for every number in this range, that for which number we are able to get the most optimal choice. All right. Okay, so this first student is going to read book with 10 pages. Can he read book with 20 pages? Yes, he can, because max limit is 60. Can he read book with 30 pages? Great. Okay, can he read book with 40 pages? Can the student read, same student, this student number 1, can he read book with 40 pages? No, exactly. So now we will need another student. So let us say our another student is 2 and he is reading 40 pages. So this student has read 60 pages, this student has read 40 pages, and our array is exhausted. Now we had 2 students, and when we are setting maximum limit as 60, we are able to finish the entire book with the help of 2 students only. Is this clear? Yes, Adarsh, you are right. Every time we will be searching for a middle element, right? The same thing that we do in a binary search. Is this clear? This number of pages, we are completely able to assign it to 2 students if we set max limit as 60, right? It means we can set our max limit as 60. That can be one of the potential answers. Now, if this is one of our potential answers, then what we can do is we can just check that if it is possible for 50. See, 60 was our valid answer, so we can check that maybe if it is possible for 59 or not, maybe if it is possible for 58 or not, and so on, right? Because basically we need to minimize the maximum page, right? So this is how we are going to operate. Is this concept clear? Select max limit, first thing. Second thing, if max limit is valid, we will decrease our limit or if it is not valid, up to 100, up to the sum of the elements, sum of all the array elements, okay, sum of all the pages, because that is the maximum number of pages a student can read. So a student is saying that, okay, I'm going to read all the pages. If it is not valid, then we will set our low as mid plus 1. Okay. If the max limit is valid, we will try to decrease the max limit, and if it is not valid, then we will increase the max limit. Are these 3 steps clear? Everyone, please give me a +1 in the chat section. Are these 3 steps clear? First of all, we will select a max limit. Okay, how are we going to select the max limit? That is on the basis of our search space, which is from 0 to sum of all the elements. All right. Once we have our max limit, then we will check if the max limit is valid. If it is valid, we will try to decrease it, and if it is not valid, then we will increase it. Okay. Okay. All right, guys, give me a +1 if we are good to go with our coding part. And we'll just code exactly what we have seen here. Shall I start to code it? All right. Yeah, thanks everyone. So let us say this is our answer. Let us say our starting point is 0 and our ending point is sum of all the elements we need to do. All right. Now we will apply binary search. This question will be done with binary search. All right, that's the approach that we are discussing here. So it is easier to do with the binary search. All right. That's the thing that you can do. Otherwise, you'll have to use loops, and that will increase the time complexity. With binary search, you can do it, you will not have to go for a quadratic time complexity. So this is just a normal binary search. All right, let me do one thing. Let me select it as maximum element. Because, we can by maximum element, because say a student will say that, okay, I will read the book with the, yes, others, that's right. A student can say that, okay, I will read book with the maximum number of pages, right? So that's why our starting point will be the max element. Now, while s is less than e, we will find our mid element. If it is a valid, let us pass our array and mid. Let's pass the size of the array as well, and the mid variable. Okay. Now, if it is a valid, what are we going to do? We will just decrement it, else we will increment our low pointer. Is this thing clear? And if it current value can. Okay, so now tell me, is this clear? And we need one thing, we need to write a condition. If the size of the array is less than the number of the students, then we will return -1. Why? Because every student must be allocated at least one book. All right. Array is not sorted, right? But the search space that we have created, that is sorted. The search space is from the maximum element till the sum of all the elements. So obviously that is going to be in a sorted manner. And then at the end, we will return yes, others. That's the base condition. At the end, we will return res. Tell me if this code is clear. All right, we need to pass the number of students as well. How to check is valid? Yes, that condition I'm just going to write. First, tell me if this section is clear, what we are doing here. All right, we are checking if current value of mid, the current max limit that we have set, if that max limit is valid. If it is valid, then we will try to decrease it, else we will increase it. All right, now let us write the valid function, how to check if it is valid. We have our vector, its size, we have the max limit, and then we have the number of students. Okay. Let us say one student will always be there. Okay, when you are assigning the books, there will always be the first student to whom you have assigned, right? Let us initialize the current sum of the pages that a student has read as 0. And now we will be iterating inside our array. Okay, so while assigning the pages to a student, what is the thing that we are checking? Just as I have explained here, when we were assigning the pages, when we were assigning this 10 page, 20 page, what were we checking for? On what basis did we decide that if we should assign this number? Yes, great, Vivek, that's the right answer. We will just check that if current sum, all right, or let us say, I will write a if condition, if current sum, and if we are assigning the current page to the student, if that is less than the max limit, okay, then we will simply add it. Okay, we have given it to the current student. Else what we will do, we will increase the number of students, okay, because now we need a new student to read this much number of pages, right? And in the current variable we will store new number of pages. Is this clear? And if any point value of CTR, the number of student is coming greater than what was given, we will return false, or else we will return true. All right. This is exactly what we have discussed. So let me know if any queries in this code. Yeah, thanks, Vivek. I just corrected it. Great. Is this code clear? Search space means the new search space that we have created, that is starting from the max element till the sum of the element. And we are applying binary search on that search element. All right. Okay, tell me one thing. Here I have taken mid as s plus e minus s divided by 2. Does anyone knows how? I mean, why basically? It should only be, starting plus ending divided by 2. Why I have written it in this way? Because in binary search we do what? Whatever the search range is there. Uh, exactly. I'm very happy to see that. Like in binary search, whatever the search space, this is our start, this is our end. We just take the midpoint, right? S plus E. But exactly as you all guys have correctly mentioned, to stop the overflow. All right. So guys, yes, let me know. Okay, and the time complexity of this code will be? Yes, Sachin, that's right answer. Vivek, Krish, Lucifer, Ritesh, Adarsh, everyone has given the correct answer. Okay, now tell me what will be the time complexity of this code? Why n log n? Okay, I will change the question. Yeah, why n log n? I mean, n log n is the right answer, of course, but why n log n? All right. Okay, tell me what is the search complexity of a binary search is log n. Okay, and as we are after applying this binary search, we are doing this linear iteration every time for the array, which will take n time, right? So that's why it is n log n. Okay, so now everyone tell me, any doubt in any of these three questions? Any doubt in any of the three questions? Like you can just replay this video, Ritesh, and then you can see that video. We need to apply binary search on sorted array, right? That's the thing. But here we have created our search space as sorted. We have just improvised our search space. We are starting it from z max element, because say if a student is saying that, okay, I'm going to read the maximum number of books. All right, so that will be it will take him the maximum number of element, right? If you will code it from 0 as well, it will give the correct answer. That's not an issue, but just to save some time. All right, guys, so I hope you all are having access to this SDE sheet. Okay, continue solving this SDE sheet. There are numerous questions there, so keep on doing that and keep on attending these sessions. We are very happy to see you all. All right, yes, thanks everyone for attending the session. See you all in tomorrow's session. Till then, keep on solving questions, keep on practicing. All right, bye, good night.